Hello, good evening. This is Naz from NB Network Lessons. Hope everyone's doing okay and in high spirits. Today, the topic of discussion is Newton's third law of motion. There is a lot of misconception in understanding Newton's third law of motion, and my aim today is to clarify things for you. So, basically, Newton's third law of motion states to every action force, there is equal and opposite reaction force. Classic definition of Newton's third law of motion. So, one thing you must understand is that when you apply force to a body, right? This is a body. When you apply force to a body, that there is a force in opposite direction also. And whenever we talk in terms of force applied on somebody, there are always two bodies involved, two objects involved. For example, if this is a pen, I'm pushing this body this way, the resistance of air is in the opposite direction. So always remember that when we talk about force, we're talking about force on two objects. For example, I push on this board right here with my hand. So my hand is applying force. However, the board is applying force back in the opposite direction. So that's why you have to understand that when you talk about force being applied, there are always two bodies, two objects involved. Um, so example is that, let's say when you are applying, when you have a spring, right? You apply force to a spring with your hand, okay? Whereas the spring is basically as a reaction applying force back to you, okay? So another thing which you need to understand is a lot of misconception that these forces in opposite direction cancel each other. They do not cancel each other. They're just applying, basically, if I'm pushing a spring, right? Okay, the spring is pushing back to my hand. My hand is pushing the spring, whereas spring is pushing my hand back. Okay. However, due to my muscle force, I can overcome the force and keep the spring in that at that position. However, if I take my hand off, spring will, basically push my hand back if I let it go. So that's why I'm saying that the misconception is that um, you know that when you apply force to a body, okay, the forces cancel each other. That's not right. Okay, that's number one. And number two is that when you apply force, there are always two objects involved in that. So let's look at an example right here. Let's say you have a ball, I don't know, maybe a soccer ball or something, okay, and I kick the ball in this direction. Okay, so I'm kicking the ball with my foot with a force. Okay, so then basically there is a force generated in this direction. Okay, this force right here is because of my foot on the ball, on ball. Now the opposite direction there is a force also. Okay, and that force is because of the ball pushing my feet. So ball on my foot. So that should give you an idea. Even though when I kick the ball goes, far away. However, there is a reactionary force, okay, from ball to my foot also. Even though that force is not that large, my force in my kick overcomes that. However, these forces do not cancel. There is no cancel. Okay. So the misconception out there that opposite forces cancel each other, but that's not true. And we will see later on in my following lessons with some examples also. Okay. Uh, Similarly, when a bird flies, bird has a wings, and the bird is flapping the wings. Okay. So the wing is pushing the air down, right? Wind is pushing the air down, whereas air is pushing the wing up. So there are two objects involved in this, wing and air. So, and there is no cancel. There is no cancellation of forces. Okay. So then you can say